Picture this. You've been on your bike for 4 hours. Rain starts, not drizzle, a full storm. The app goes offline, the roads close, your zone gets flagged. And just like that, your entire day's income is gone. No claim form will save you. No insurance company covers this. You just lose. And you move on. This happens to 1.1 billion people every single day. They're delivery riders, ride-hail drivers, freelance couriers, the people who keep our cities running. And not one of them has financial protection when the world disrupts their shift. We ask one question, why? And then we build the answer. This is HustleSafe.
Now, with the core idea behind HustleSafe's creation being clear, we move on to the system design part. HustleSafe has two types of users. The first is the insurer, who acts as the administrator monitoring the entire system, logging in using admin username and password. The second type of user is the worker, who logs in using their mobile number and OTP service. Firebase acts as the external authenticator in both cases, handling connection with the Supabase database system. In HustleSafe, the insurer can monitor GDS scores of multiple areas. They monitor current GDS and future predictions. We have incorporated an LSTM model predicting the trend of the next 7 days, while also keeping a more accurate hourly GDS measure. While the insurer has a global view, a worker can access their specific zone's expected GDS trends for the day. The premium is calculated weekly based on the LSTM's prediction. The worker learns of a specific premium while total capital is shown to the insurer. However, the hardest engineering challenge wasn't calculating the premium. It wasn't paying claims. It was making sure we only paid the right claims. Parametric systems have one major vulnerability: fraud. If you can fake a location, you can fake a disruption. We built a system that makes that economically irrational. At the core is our Ensemble fraud scoring engine. Our primary model is XGBoost, version 2, status aware, trained on historical fraud patterns, processing 12 or more signals per submission, outputting a continuous fraud probability score in real time. The worker's location is monitored through GPS and location parameters like rainfall, temperature, and wind speed using OpenMeteor API. Every claim goes through a 2-pass pipeline. Pass 1 is lightweight. It runs on every single submission. GPS coherence, weather correlation, peer density in the zone. If the score is green, the worker gets paid instantly. If it's amber, we escalate to Pass 2. Pass 2 is what we call the deep adversarial analysis. We check cell tower ID against GPS coordinates to catch location spoofing. We analyze accelerometer jitter because a bot moving through fake coordinates has a completely different sensor signature than a real human on a bike. We run coordinated ring detection. If 5 devices are moving in an identical pattern, that is not 5 workers, that is one fraud operation. Every worker also has a living trust score, 0 to 1, that evolves with every claim and every interaction. Top-tier trusted workers get instant payouts with minimal scrutiny. Newer accounts get tighter gates, thus the system self-adjusts. On the financial side, every single payout runs inside an atomic PostgreSQL transaction. Double payment is structurally impossible. The moment a claim clears, a server-sent events stream pushes the balance update to the worker's device. There is no polling, there is no delay. Heavy ML inference is offloaded to a Celery and Redis queue, so the main API stays fully responsive even when we are processing thousands of disruption events simultaneously. Firebase OTP authentication, Stripe payments, Supabase managed database, frontend on Netlify, backend deployed on Render. This is not a prototype, this is a production system. Let us address a final criteria. What if there is a cause of disruption beyond weather? What if there is a hartal or a serious accident and the roads are blocked? In such emergencies, the insurer can trigger a disruption manually. For instance, let us take Koramangala. Imagine a major road blockade occurred there. The insurer can set up the disruption with a simple trigger. Delivery partners in the area are immediately notified of the crisis, and the system updates its claim requests. In such emergency cases, the premium amount is boosted beyond the original to compensate for losses, as emergency lockdowns often have a more drastic effect on the work economy. The boost is also calculated using the same Shapley score that calculated the standard premium. Once the blockade has ended, we end the disruption to show return of affairs to their normal state. business resumes. To review what has happened in the background, we move to the feed of the worker, who has received his rightful claim after clearing the fraud check.